So in this video we are going to show you the process of online storage migration. Basically we are going to migrate two volumes from CEPH and NFS to the SolidFire while the VM is running. We can observe the VM is running on particular host, and then we can check its volumes. We have one root and two data volumes. The root volume is already on SolidFire, so we are not going to migrate this one, obviously. Then we have first data volume on NFS. Yes, you can see over here. Then we also have another data volume which is CEPH based. It's obviously on CEPH, and basically now let's show you how this looks below the surface. If we start the CloudMonkey command, we are using the new API call or new API command, which is available in 4.11 release, migrateVirtualMachineWithVolume. We are specifying virtual machine ID, which is basically the virtual machine whose volumes we are going to migrate, and it's also going to happen live migration of this VM to another host, so we are defining the host ID as well over here. Then we have migrate to parameter with two subparameters and identifier. migrateto.pool is the pool for the volume with the identifier 0, and then we have migrate to with identifier 1 for the volume with identifier 1, which is the second volume. So we have basically a pair of new destination pool and the volume that's being copied over to this volume. So here at the CloudStack GUI, basically what we need: VM UID, we need NFS volume UID, we need CEPH volume UID. Then back to the infrastructure, we need destination host UID, as shown in the GUI, or ID for that matter. Sorry, that's ID, but in database it's actually UID. And we need a SolidFire volume ID, or SolidFire pool, not volume, sorry. So SolidFire pool ID, and let's now start the API call. For now this is only available via API call or CloudMonkey for that matter, not yet via GUI. If we check the VM, we will see it's in migrating state. If we check the root volume, it's in ready state because we are not migrating that one. And then if we check NFS and CEPH volumes, they are both in migrating state because we are actually migrating these two volumes to SolidFire. So let's just refresh actually the SolidFire GUI. We can see at the top two new volumes with no name. Let's manually refresh it once more, although it's automatically refresh each 10 seconds. And now you can see actually two volumes created, and with a certain write throughput at the moment. What I'm going to do, I'm going to go to management. I'm going to increase the max IOPS of these two volumes, because this is the speed which is a maximum theoretical write speed or migration speed actually to SolidFire, either for offline migration or online migration, which we're doing right now. So let's put around 15,000 IOPS for both volumes being migrated. So this is new volumes which are created on SolidFire, and it will be in the background delivered NBD, or actually Camo NBD driver is doing the block coping operations. So if you observe the performance tab again and then volume performance, imagine you can see detailed performance per volume for all your volumes. Really nice. You can see now it has finally reached around 100 megabytes, which is translated in a non-linear way to around 15,000 K in IOPS in SolidFire. On the physical nodes, if you check the destination host, we'll see there is a new VM over here as well, but in a pause state, and it's actually using SolidFire in the XML definition, not NFS. Here we show you we still have obviously two volumes, data volumes inside the VM, and basically from this moment onward I'm going just to keep these two windows in parallel, just to show you on the total write you actually have the total throughput, or actually that's a write throughput on these two volumes. You can actually observe the some throughput on the root 12, which is third volume from the top root 12 volume, which is the original already existing, let's say, SolidFire root volume. The reason for this is because in CAM or Liver there is no way to escape this internal coping operation as well over here. So this is not due to cloud stack, due to SolidFire. It's simply let's say limitation of the KVM. Here is the live migration, very briefly completed. No more VM on this source host with certain name. If we check on destination host, we see that we have a VM now in the running state. So basically the source VM, which was using NFS volume, was finally cloned over instance of volumes, RAM, memory as well, destroyed on the source host, and then created on the destination host. Back to the SolidFire GUI, we can observe 0 volume throughput because no workload inside it. If we refresh in the GUI, the VM, it's now again in the running state, and obviously both volumes are in a ready state. If we actually check these volumes, we can observe they are now on SolidFire storage. You can observe this and do all these actions only as a root admin, obviously. But also, if you actually check the volumes, you can observe that it's using, in our case, old NFS disk offering, and we do have different tags on NFS versus CEPH versus SolidFire offering. So we really need to actually change these. Let's quickly stop the VM. As you can see, it's already down, and let's just go and change offering. It's official the resize button, all right, but change offering to the same size but SolidFire offering. And we can do this. We need actually to do this, in our case at least, here for both volumes. In case you are having same tags across all storages, then for you there is no issues, I guess, at all. You don't need to change the offerings. Simply there's nothing actually you can change to. But in our case, it's an important part for billing and usage purposes, because we have different storages with different tags and then offerings with different tags. So basically, if we go to the destination host and we just do, for the sake of fun, dump XML of the new VM, destination VM, where it was migrated, we can actually observe a little bit above. It's all SolidFire volumes which are now referenced, which are mounted locally as almost basically local disks from the Linux side, physical server side. But we can observe one root SolidFire and then two data SolidFire volumes.